Alright, now we are going to look at Unit 4, Lesson 8, and this is sine and cosine in the same right triangle. So the first thing I want you to look at is 8.1. If you will, pause the video and look at A, B, C, and D. Which one do you think doesn't belong? And see if you can find a reason for each one not belonging with the group. Alright, pause the video and take a second to do it yourself. Okay. Let's look at A. One thing that I put on A was it was the only one that we could use cosine. So if I took cosine of 70 degrees, remember cosine is adjacent, so I have my adjacent side here over my hypotenuse. So we could find x, solve x with using cosine, whereas on part B, we have the opposite side, so this would be sine. And it's the only one that we can use sine, opposite over, oopsie, no I didn't, I have tangent, my bad, tangent. So it's still opposite over adjacent. But it's the only one that we can use tangent with. My fault, guys. It's also the only one that used a y as a variable. C. This one is not a right triangle. So if it's not a right triangle, it's the only one that we cannot use the trig functions. And what I mean by trig functions, that is your sine, cosine, and tangent functions. Alright, and then with D, this is the only one that only has your 90-degree angle marked, doesn't have the other two marked, and it also has the variable as your hypotenuse, whereas all your other variables are your shortest sides. Alright, so this was just to kind of get you to start looking at triangles again, and just comparing how can you solve them, cosine, sine, tangent, not a right triangle versus a right triangle, what information is given to you. That was the whole purpose of this. Alright, so let's keep looking. Alright, again, I want you guys to find the values, and I want y'all to try to do this on your own. So pause the video, work on this on your own. One thing before you pause though, make sure you write this at the top so you have this information. Again, I just feel like this helps to give just a quick glance of what you're doing. Okay, now pause the video and try to answer A1, B1, and then you can, if you want to play the video after you solve that and see if you're doing it correct, great. And then pause again to do A2, B2, and check your answers. Okay, for A1, we're given 41 degrees, and we're given the adjacent side. And we're looking for the hypotenuse side. So I like to go up here, adjacent and hypotenuse. So I'm going to be using cosine. So I have cosine of 41 degrees is equal to adjacent first, so adjacent is 7 over hypotenuse. Okay, so from there we're going to solve for x. And type that straight in the calculator. And I've added another calculator onto your resource on your weekly checklist page that I think is a little bit easier to use, but either one works. So if you type this in the calculator, we find out that x is equal to 9.3 units. Okay, let's look at B1. So B1, we're given this angle 49 degrees, but we're given opposite, and we're trying to find the hypotenuse. So opposite hypotenuse, we're going to use sine this time. So sine of 49 degrees is equal to opposite over adjacent. So hypotenuse, opposite over hypotenuse. And now we're going to solve for x. Plug that straight into your calculator, and you find out that x is 9.3 units. So hopefully what you notice here and here is you get the same answer. And so that's what we're going to be discussing down here at Compare Your Solutions A1 and B1 and A2 and B2. So if you're playing the video right now and then going back and trying A2, B2, then it looks like you're going to be getting the same answers. So that will help you to check yourself and make sure you're doing it correct. All right. So now let's look at A2. And this time, this is the angle we are using. So I'm given the opposite side and the hypotenuse. So opposite hypotenuse, I'm going to be using sine. So I have sine, of 65 is equal to y over 6, opposite over hypotenuse. I'm going to multiply both sides by 6. Type that straight in our calculator, and you get 5.4 units. Okay, jumping over to B2. Now we're looking at 25 degrees here, but I'm given the adjacent side. So now I'm going to look at cosine. So cosine of 25 is equal to adjacent over hypotenuse. So remember, this is your adjacent. Again, these little notes help make sure you just get everything in the right ratio. All right, solve this. Multiply both sides by 6. Type that straight into your calculator, and you should come up with 5.4 units. All right, so again, 5.4, 5.4. So how can we compare this? So let's pay attention to the angles. 41 plus 49. Let's add that together. 41 plus 49. We're going to get 90 degrees. And then let's look at A2, B2. 65 plus 25. We're also getting 90 degrees. So if we've noticed, what we've done is we have the same triangles. Because if this is 65, that means this is 25 degrees. If this is 41 degrees, that means this one's 49 degrees. So, and then this is 41 degrees, and this is 65 degrees. So, what we found out is these are the same triangles. And the angles, because the angles are complementary, so what we just found out here is we used cosine, and if you look, let me highlight. If you look here and here, you notice that they're both 7 over x. So, if we know they're both 7 over x, then we can say cosine of 41 is equal to sine of 49. So we see that one angle that's cosine is going to be equal to the opposite angle for sine. And we did the same thing right here. Right here, if you notice, here when we set this up and this up, y over 6, y over 6. So again, sine of 65 was the same thing as cosine of its complementary angle. All right, so again, these are little shortcuts that help you in geometry and trig functions at finding different sides. Okay, so this is where this looks a bit confusing, but this is just what all of this says right here. So this little symbol we call theta. This is like your x in algebraic equation, solving for x. This is the variable we use for angles. Okay, you'll see theta. It's the Greek alphabet is what it is. You'll see theta, you'll see alpha, and you'll see beta. These are the three most common ones that you use. So don't get stressed out whenever you start seeing that in equations. It's just variables like x, y, z. Okay, so we're going to draw a diagram. So we obviously know if we're drawing a diagram in this unit, it's going to be a right triangle. So what this one is saying is I'm going to let this angle be theta. If this angle is theta, now let's write our SOHCAHTOA. SOHCAHTOA. I'm wanting sine of this theta angle. So if I'm wanting sine, then I'm wanting opposite and hypotenuse. So this is my opposite side. This is my hypotenuse. So that would be my sine of theta. And we're going to say it's equal to 90 minus theta. Well, we just learned, we know that this angle right here is always going to be the difference of 90 with this angle. Okay. So that's why it looks confusing, but that's just saying if we know this is 30, then 90 minus 30 is going to give us 60. So that's how that works. All right, now, if we want cosine, cosine is adjacent over hypotenuse. So if I'm going to do the cosine of this one, then I want adjacent. So then this side would be adjacent over hypotenuse. So let's plug into some variables in here so we can set up a ratio. Let's call this side x and this side y. So if I want sine of theta is opposite over hypotenuse. Cosine of 90 minus theta, so now I'm looking at this angle, I'm wanting the adjacent side, which is also x over hypotenuse. So we see here we're getting the exact same ratio. So that's why these two are equal to each other, because both of them are going to be x over h. So we end up getting the same ratio there. And I hope that explains. If you still have questions when we have one of those live sessions, please ask. But just remember, whenever you change angles, your adjacent side, your opposite side, all that changes and switches it. Okay. Once you watch this video on Tuesday, I'm going to post your cool down. So you need to watch this video by Tuesday. Then you're going to have your cool down. You have to an exit ticket first. So let's look. Hopefully, if you're staying on schedule, on Monday after you watch this, so you have the video and then you complete that exit ticket. And it's just a couple of questions seeing if you understood what we did on this lesson. Tuesday, I will post the cool down for you to complete. Okay, and then Wednesday, I'll have another video that I'm about to do right now and go ahead and link to this. So if you want to watch all the videos now, that's fine. But then I'll have this cool down posted on Thursday for the next one. All right, again, I'll have live sessions on Tuesday, and I'll have a live session on Thursday, and then I'll see about Friday if we still need to do one. Don't hesitate to email me, and we can go from there.